And that's why in the last video, we completed our installation as Null0 Labs ISP services, and we delivered fully redundant, dual-homed internet service to Uday's data center as our customer. And now we continue our journey as Uday, and we are going to configure the customer side of the connection. And we're going to explore that journey together. First thing we need to do is on our internet switches. So at the moment, we've designated as the customer that we want our ISP to plug their, we're going to plug their internet service into a VLAN, and we've decided that we're going to put that in VLAN 999 as our outside VLAN. Here under this diagram, we are using external switches and internal switches. In between, we have a firewall. So we are going to configure these devices now to get to the point where we can manage the Palo Altos, set up a HA failover internet firewall, and we're going to set up an access layer switch that could be somewhere else in the building, first floor, ground floor, VLAN 10 with a desktop client, and it's going to get access to the internet. Before we move on, I've added that we can have full reachability now to the full internet rather than to a test point. So from perspective of these devices, they will be able to access fully onto real world live internet. So let's start with switch 1 and do the basic configurations to get VLAN 999 in place. So we're going to create VLAN 999. We're going to put this interface, this interface, this interface, and this interface as so this one here, and this one here, this one here, this one here will be VLAN 999 switch port mode access. We want to trunk that VLAN across here. So these two, G0/0, will be operating in trunk mode. We're going to get that set up and get VLAN 999 in place so that VRRP can function correctly between these two devices. And then we'll move on to the switches here, and then we'll move on to the firewall. So let's get cracking with that. Hopefully you can still see the diagram and that at the same time. So EN, so we are on, we're going to give it a host name because we'll get lost otherwise. So the host name for this switch is iSwitch1. Okay, then we're going to create a VLAN. We're going to create VLAN 999. We're going to give VLAN a name. We're going to call it the internet. Nope, we're not. We're going to call it Null0 Labs -ISP. So we know that that's what that is. And I'm going to go int G0/1. We're going to go, right, this is our primary internet feed. So description, primary, well, P-R-I, no, P-R-I, P-R-I, Mary, that's better, internet feed. And then we are going to say you are switch port mode access, switch port access VLAN 999. No shut, just to be sure. Good. So we now know that that is our primary internet feed in that VLAN 999. G0 on the other hand, so int G0/0. Description, this is a trunk to iSwitch2. I'm going to shorthand that. Switch port trunk encapsulation. We want .1q. And we're going to go switch port mode, trunk, no shut. What a trunk does, a trunk carries all VLANs. Access port modes only carry the VLANs that you tell them to. So in between switches, we want to carry as many VLANs as we specify. When we're setting up a switch port to a server or a device, it's going to have the VLAN that we specify. The next one is int g0/2. Description. We're going to call this outside FW1, because that's where it's going. And it's going to be a access port. So switch port mode is going to be access. Switch port access is going to be a VLAN 999. No shut. Be sure. That, for this simple lab, is all we require. Let's jump on to iSwitch 2. Nice. Same thing again. We're going to give it a name. The host name for this switch is iSwitch 2. Then we're going to create a VLAN. So VLAN 999. What I'm looking for, name. What did we call it on the other side, just so that we can be matching. Show VLAN 999. Null0 Labs ISP. Okay, so we'll copy that. Then we'll give it the same name. I've got a fly flying around. Super annoying. All right, in G0/1, it's going to be in switch port mode. Access. Switch port access is going to be VLAN 999. And that should be it. No shut, just to be sure. We're giving it a description, blah, blah. No, we haven't given it a description. Description. This is on the other side. What did we say? Did we say primary, or did we use another? We said description primary internet feed. We will use backup internet feed. There we go. So let's do show IP in brief. No, on the switch. So do show int status. So G0/0 is a trunk. Good to know. And that one is in VLAN 999, which is what we want. So next we want to do this one, G0/G02. So no, we're going to check that trunk port first. G0/0. 0/0 switch port mode trunk. No, switch port trunk encapsulation. On the higher end Cisco switches, you don't have to worry about this command. You can just literally go switch port mode trunk. You know, some of these older ones in iOS, you have to remember to set the encapsulation, because you could set other types like ILS or negotiate. I don't think I've ever come across anyone where I've turned up and I've looked at a switch port and I've seen the switch port configured in ILS mode. I've only ever seen .1q. So I think maybe that's why I think it was probably like a VHS Betamax type thing. Maybe that's why eventually everyone just decided, yeah, .1q. Right, so we have set .1q. Now switch port mode is going to be trunk. And we are going to say that it is a trunk to ISW2. There we go. We're just going to say no shut just to be sure. Now we'll move on to G0/2. Description is going to be, I think we say over on the primary side, outside FW1. So this will be outside FW2. And switch port mode will be access. Switch port access VLAN 999. No shut. Now that should be it for the two outside internet switches, because that's all they're doing is they are just operating in a simple layer 2 configuration to allow VLAN 999 come in, basically the internet to come in, VRP packets the flow between these two devices. And then we want the outside interfaces of these two firewalls to be in the same VLAN, because we want their outside interfaces to have an IP address at layer 3 within that same thing there. So now we want to get management access to these. Now I've cheated a little bit. The only things I've done is on the management interfaces of each of these devices here. They do have a management interface, and the management interface, I have pre-configured a management interface of 192.168.99.10 and 99.11. And this management PC, I think we have to configure it, but I might have already done that. If I've already done it, it'll be good, because then we can just jump straight into a web interface and we can start configuring the firewall. Now let's jump on the two internal switches. Uday's been lazy. He hasn't bothered to give these names, but I think it's because he's put these in temporary, because what we're planning to do later is that Uday is planning a massive upgrade here in the data center to a Nexus VPC pair. So later on, there'll be a video coming of us swapping these out for a VPC Nexus pair, so that we then don't have to rely on things like spanning tree to block one of these links down here. We can just LACP these up to the switch and have a pure 20 gig trunk rather than two 10 gig trunks coming up into the switch. So let's start with getting the management VLAN, which is 998. Okay. Right, so we are on switch 10 and switch 9. So let's look at switch 9 first. Let's give it a host name. So the host name will be, I'm just going to say SW9. That's not where the tennis is it? And then we want VLAN 998. So we're gonna create that. So VLAN 998. Name MGMT VLAN. We know what it is. Right, so we know we've got a management PC down there, so I'm going to put that straight away. So in G0/2, switch port mode is going to be access, because we know we've only got one device on there. Switch port access VLAN 998. That's the VLAN we want to allow access. And we are going to give it a description, MGMT PC. The one PC that you can configure everything from. No shut. Cool. That's that interface. Right, the management interface for this is G3. So in G0/3, description is going to be FW1_MGMT. Switch port mode is going to be access, switch port access, VLAN 998. So that should be enough for that port. We might as well set up the trunk between the two switches just to start. So int G0/1, description, because we want to carry multiple VLANs between this switch port. So description trunk _2_SW10. Switch port trunk, you guessed it, encapsulation like anything is .1Q. Switch port mode is going to be a trunk, no shut. That's it. So WRMem, I'll do for now. So we have configured this one to be in, we've configured VLAN 998 on G02, 998 on G03. We've set up the trunk between the two switches. We'll now jump over to switch 10. And we're going to do pretty much rinse and repeat. That's the one thing you'll find when you're doing high availability. You always end up having to do the same thing twice. Because that's the whole thing of high availability. You have one thing and you duplicate it. So over here, we're going to set a host name. So the host name is going to be, I'm going to cheat again. I'm just going to call it SW10. And I'm going to set up a VLAN of 998. And I'm going to call this the MGMT VLAN. Name MGMT VLAN. That's what I'm looking for. We're going to start with the trunk. So int G0/. Ooh, did I make a mistake? No, G0/1. Good. Int G0/1. You can see how we make mistakes because we're always looking at things going, oh, is it int G0/1? Or if you get on some of the other bigger boy switches, where you got int G0/0/0/1, you can find yourself getting confused sometimes. So you always have to find that you're constantly having a double check. So this is going to be a trunk _2 SW9. Good. Switch port trunk encapsulation is going to be .1Q. Switch port mode obviously is going to be a trunk and no shut. So now we have a link between the two switches here. So this link here between the two switches is a trunk. It will carry VLAN 998 from this one over to this one. It will carry VLAN 10 when we set it up from this one to this one. It will carry multiple VLANs. The purpose of a trunk is that it's designed to carry multiple VLANs. So the next one is the management interface going towards the firewall, which is different on this switch. I think that's because we had somebody called Peter plug the cables in the wrong way around. You'll have to double check. So int G0/2 on this one. Okay. So config T int G0/2. Description. This is FW2_MGMT. Switch port mode is going to be access. Switch port access is going to be VLAN 998. And we will no shut it. So int status, let's double check our work so far. We have a trunk configured between the two switches. We have a management port connected towards the firewalls on both switches in VLAN 998, and on the switch over here on switch 9 we have a special management PC that we are going to use to manage the Palo Altos. So next we're going to jump on here. We're going to set up the HA of Palo Alto. We're going to test that we get internet connectivity. We're going to assign ourselves one of the IP addresses out of Null0 Labs ISP's pool that they assigned us. We know that they have used 1 for the default gateway. They've used 2 for the physical interface here. They've used 3 for the physical interface there. So the next available address is 4. So we're going to go with 4. And that's it, because thankfully the firewalls of Palo Alto allow us to use one address and just move it between the two devices. We don't have to do this funky, crazy stuff where we use up 3 IP addresses just to do HA, which is nice. Right, so we should now be able to launch this management PC. Which we can. Let's put it there. I was using the old one. If you'd watched today's live stream, we built 2 new VMs for a future lab that's coming up. So look out for that. 2 hours to build 2 VMs, but we've got everything we need. So start X. What we're doing here is that we've booted a virtual desktop environment window manager so that we can do Firefox. It's like the bare minimum of what you have to do on Linux to get some kind of desktop application running without having to have a full-blown desktop. So it cuts down on resources, especially when you're using everything in a virtual environment. 192.168. What did I say? 99.10. HTTPS, wrong protocol. All right, so default admin. And we are in like Flynn to the primary. It's a bit slow. Running a bit slow. I'll give it that. See if we can get access over to the second one. Okay. Oh, they really are taking their time to boot up, aren't they? Come on, you can do it. Give me a desktop. Whilst we're waiting to get management access on that, let's do this VLAN 10 actually on these 2 switches as well. So VLAN 10. Description, no, name is our floor. And we'll put int G0, no, because what we're going to do is we're going to go int G1/0. So this is going to be FW1_trunk. Again, switch port trunk encapsulation is going to be .1Q. Switch port mode is going to be trunk. because we're going to do all the layer 3 up here. No shut. Do the same over here. We'll create VLAN 10. Name going to be ground floor. Int G0/3. Switchport mode is switchport trunk. Sorry. Encapsulation is going to be .1Q. Switchport mode is going to be trunk. Description. What do we call that one over here? FW1 trunk, FW2 trunk, FW2 trunk. Trunk even. Okay, so that should cover both of them. Are we at desktop? Yes, finally. Right, do not share any telemetry. Remind me later. No. Close. Remind me later. Right, so firewall 1. Jump over the device. It's got a management. Got a management address. Yep, that's correct. How we're accessing it. Got a name, firewall 1. Thankfully, we pre-did that. Right, so network first. So we're going to look at these interfaces. We're going to specify these as our HA interfaces. We're going to use them for high availability only. So we're going to look at the first one is, let's do 1.7. We're going to set that as HA. We're just saying that we're not using that interface for any services other than high availability. So we're going to do that for both of them. We'll commit that. Whilst we're waiting for that to happen, we'll jump over to the second one, this one here. We'll do the same. So we want these to be HA. Okay. Want this to be HA. We're going to commit. So we've now said to the system, hey, don't use these. Don't use these two interfaces here for any traffic. Only use them for high availability operations between the two devices. So that's what we specified. On a physical hardware, it's different. On physical hardware, there is designated HA ports that you will use. But you do also have the option to specify other ports within the chassis to be HA pair as well, because obviously these are VMs, so PAVA VM. So it's a virtual Palo Alto, not an actual physical Palo Alto. So now we see they are both HA. Good. So the next option on phase 1 is to let's get the HA functional. So see everything that we need to see. Yeah. Okay. Right. So we're gonna enable HA. Gonna give it a group description FW-HA. We're doing an active passive, which means one device will be active, the other one will be sitting there not doing much, and it will take over in the event of the other one failing. Active, both of them will be running at the same time, and traffic will be flowing out of both of them, but we're doing an active and a standby type scenario. So we're going to appear to 1.1.1.2. These are, actually no, I'm not, because I'm going to practice what I preach. I don't like doing it out of those subnets. I'm going to do it out of, I'm just going to do 192.168 dot I'm going to go with 200.2. No, 200.1. So I'm saying that I'm 192.168.200.1. I'm going to set the passive state on the other ones to auto because speeds up failover. And again, I want this one to be the primary most of the time. So I'm going to set it to be the primary and preempt any lower devices. Now we're going to jump over to this HA communications tab. We're going to set up HA1. The port is we'll use 17. So here. Hold on. This is where I made the mistake. I'm going to peer to 2. And I'm going to be .1. I'm going to be 192.168.200.1. 252. Don't need to worry about a gateway because they're directly connected. And so that's HA1, and then HA2 for the data link. We are going to use port 8. We don't need to specify an IP address because we use an Ethernet. And okay, that's that part done. I'm going to leave this for the time being. We'll come back to that later. I'm going to hit commit. Now I'm going to go and jump over to this side. And we're going to do a similar config. Get them talking. I'm going to go to HA. I'm going to enable HA. It's group 1. I can't remember what I called it. FWHA. FWHA. And it's going to appear with 192.168.200.1. Same again, auto. I'm going to set this one 50. It's going to have a device priority as lower. We're not going to do preempt because we don't want that to happen. We want the primary FW1 to be the device. Oh, it's named wrong. Okay, I'll change that. And we'll set the, and we used 7. So this is 192.168.200.2. And this is the interface that the other device is going to use to communicate with. And we are going to set the 8 as the one that manages all the session traffic. Hit commit on that. Jump back over to switch firewall 1. We can see that that's happened. Let's rename this because I don't like the fact that it doesn't have a 0 in front of it, and my ADHD will be like, there's no 0 there. So we will fix that. So once this is done, and these are both committed, we will end up technically only really having now to log on to FW1 and doing our configuration, because everything that we configure on FW1 will now be duplicated to FW2, and firewall 2 will just have a exact copy of what's on firewall 1 and take over in the event that we switch firewall 1 off, or we do an update on firewall 1, or firewall 1 dies, or it fails over. Then it will move over to firewall 2. But until then, everything will run on firewall 1. So let's double check. Let's go back to the dashboard now. Let's add You can add a widget, add high availability, that's better. We'll do that over here as well. We'll go back to dashboard. We will come up to widgets and we'll we will add the high availability widget. We can see it's not synchronized yet. Not synchronized, but we can see our HA1 and HA2 interfaces are up, which is what we configured, and we are happy that they are functional. Let's just refresh that. So, okay. And now I'm going to push the first configuration over to the second one. Why we need to change to my new VM. Takes forever for that to refresh. So once we get this operational and we see that everything is synchronized, we will then have technically what will appear as one firewall on the network. Similar to how here we have that virtual router, this 51.100. It doesn't matter which one of these fails. The devices downstream will only see this virtual device. The same thing will happen here. We'll configure these will now be operating as like technically one virtual device across two physical pieces of hardware, and the devices downstream here are oblivious to the fact that there's actually two physical pieces of kit here. So we will now synchronize from firewall 1, firewall 2. And we can see that the synchronization is in progress. We can see that it knows that this local device, firewall 1, is the active device. We can see it's the active device right here. So local is the active. The peer is the passive. Obviously, it's showing the management address. And the synchronization is now in progress. Over here, we can see the active peer is the management address of firewall 1, and the local device is the passive device. We hit refresh, we can now see that everything's synchronized, everything's all green. This orange here for the amber, that's perfectly acceptable, that's correct. And same over here. Synchronized, matched, everything's up, everything's all synchronized. We now technically have what appears as one firewall spread across two physical pieces of equipment. Now the next step is to get internet service operational. So we're going to close firewall 2 for the time being, because we don't technically need it anymore, because everything that we do now on firewall 1 is going to replicate over to firewall 2. The first thing we need to do is we need to get the ISP interfaces operational. We know that's Ethernet 1 on both of these devices. So we're going to jump onto Ethernet 1. We're going to set it as a layer 3 interface. We're going to assign it to the default virtual router, and we're going to create a new security zone. For simplicity, I'm just going to call this outside. So it's an outside interface, similar to how you used to do in the old days in Cisco, where you got outside and inside, but this is like a security zone. It's not a NAT thing. Right, so then we're going to set an IP address. The provider's not doing DHCP, so we're going to do it as a static address, and we know that our first available one after that is .4, because they are using 1, 2, and 3, so we're going to use 4. So our public IP address on the firewall is going to be 198.51.100.4, and it's a /28 mask. What was a /28? Yeah, the /28 they gave us. So we've done that. We're not doing IPv6 at the moment, not today. Advanced, we're going to come in here, we're going to go to management. At the moment it says none. We're not going to put any management profile on there, but what we are going to allow is we're going to allow ping. So we're going to create a new management profile and we're going to call it ping only. And what this does is this allows us to ping that public IP address from the internet so that we can verify that it's online, but we can't access any of the management services of the device. So that's all looking good there. Don't need to change anything else. We're going to hit on OK. Next thing we're going to do is we're going to jump into virtual routers. And we are going to do a static route, a default route. So we'll call this default. Again, as I can spell. Destination anywhere. Technically, it's going to go out of ETH1. The next hop is going to be a 198.51.100.1. We're not going to change any of the admin distances. We're not going to change anything else down here. Four zeros. Click on OK. Better. Right, so we'll commit that. That's going to commit. And so what we've done is we've configured on here, we've configured our first usable public IP address onto this interface, and we've set a default gateway towards the VRRP address up here. So we've basically gone public IP, everything else here, which allows it to fail over. So what we'll do now is we'll do a test to make sure that we can ping our default gateway, and if we're lucky, we'll be able to ping upstream further. Synchronized, so the config went across. Good. Now I can't see that bit that I wanted to get to. Was there a web GUI for it? No. What we will do is we will there is a button over here that I can't get to because of the maybe if I zoom it out a little bit. Yeah. That should be. Right, what have we done? Right, so we've got the virtual router, we've got outside interface done. Let's do the inside interfaces, then we'll move on for a test. So we'll do the inside interfaces first. Bring that back up. All right, so interfaces here are different. This is going to be technically this is going to be a trunk interface. So what we're going to do is we're going to select this one. We're going to make it a layer 3 interface. And then what we're going to do now is we're going to set a ID. So this is going to be VLAN 10. So I like to match them. This will be VLAN 10. And it'll be part of the default routing. And nope. We're going to give it a new zone. We're going to call this VLAN 10. Zone. And we're going to give it an IP address. Do we have an IP address range? VLAN 10, 192.168.10. So what we will do is we will go 192.168.10.254/24 because I like to use upper end. And we'll allow the inside to ping the inside interface just for testing, and we will hit OK. So we will commit that. What we might do actually is to cheat. What we'll do is we will allow firewall to deliver DHCP services for VLAN 10. So we'll get this bit, we'll get that bit configured, then we'll configure down here, and then desktop should be able to get an IP address from DHCP off the firewall, and then we'll be able to test reachability straight out onto the internet. The goal is to get reachability. So we have VLAN 10 has got an interface configured on the trunk. Good, that's what we want. Let's put some DHCP services on that interface as well. So we're going to put it on 2.10. All 2.168. What was the range? 10. 10 dot say 1 to 192.168.10.100. That should be more than enough. We don't need about reserving addresses. Ping the IP when allocating a new one. The gateway is going to be 192.168.10.254. Mask is going to be 255.255.250. And we will use 1.1.1.1 and 8.8.8.8. I'm going to change any of those other options on OK. Commit. So we've configured the outside interface. We configured the inside trunk interface. Configured D8 inside trunk interface here, outside interface there. We've configured DHCP. Next, we will NAT the inside to the outside, and we will allow the inside network to access the outside network. Then we'll finish up our switch configuration and check from the PC. So we've done that. Let's jump to my policies now. So NAT, let's create a NAT rule. And we'll call this a source NAT. So we're going to say we'll say from any of the inside zones to the outside zone. Coming with an address of 192.168. Start with 10.0/24 to any outside address. We want to IP import, and we want to translate it to, what did we say it was? 198.51.100.4. So what we're saying here is that from any inside zone that this IP address range comes from, we're going to add others later. Going to the outside interface, if it wants to access any service beyond that interface, use that IP address and NAT the traffic. That will give us our, technically the same as our like source overload NAT, overload NAT. So that's what that's going to do. And now we will add a security policy to say, hey, anything coming from the inside zone to the outside zone, allow it. And then we will then be able to configure the switch and the desktop. The desktop should then get an IP address and should then be able to access the internet service. And Uday will be happy that his DC has internet access and he is good to go. So security zones, let's add a zone. Internet. From any zone, 10.0/24, and you want to go to outside, any address, any application, any service, will allow that for now. Needs to zoom out. Oh, is there a way to adjust this? Outer window. No, that's not what I wanted. I just want to be able to see the doing what I want. Just reduce the size of it so I can see the button that I need. There we go. Right, so we've got an internet rule allowing that inside zone to go outside. Okay, so that should be everything we need to get that internet up and running for that VLAN. So let's minimize this out of the way. Let's look at these other switch ports. These are going to be, jump on here first. So this is going to have a host name of, I'm just going to call this access SW. I'm going to give it VLAN 10. It needs to be aware of VLAN 10. Name was ground floor. Now in G0/2 is going to be switch port mode access because it's going towards the client. Switch port access is going to be VLAN 10. No shut, description, client, port. Next, we're going to do in G0/0. Switch port mode is going to be switch port trunk encapsulation. Going to be .1Q. Switch port mode is going to be trunk. No shut, and this will be description. This will be link to SW9. In G0/1. This will be a link _to_SW10. Switch port trunk. Encapsulation is going to be .1Q. Switch port mode is going to be trunk. No shut. We're going to have to worry about spanning tree in a minute, and we'll take a look at that. Well, we pre-configured these, didn't we? Show int status. No, we didn't. So config t. Config t. So in G0/0, switch port trunk encapsulation because we've got 1Q. Switch port mode. Going to be trunk. Description to _access W. No shut. Jump on switch 10. We'll do the same. Going to want to manipulate the spanning tree in a minute to make sure that the main route does actually go up to switch 9 the majority of the time. In again G0/0. Switch port trunk encapsulation is going to be .1Q. Switch port mode is going to be trunk. The description is going to be to _access switch. No shut. Spanning tree. Mode. I want rapid. Do the same on all of these. Make sure they're all running the same. So which one's being blocked? So the root port is G0/0. The alternate port is G0/1. That's good so far. We are all in forwarding mode. So G0/0, G0/1, G0/0, all in routing mode. So 10. Right, VLAN 10. So this is where Okay, we'll manipulate that in a minute. Let's get the client up first. What I want to do is I want to make sure that this is the primary, this is the secondary, and I want the block to be placed somewhere down here. So we will check that in a minute. Let's jump onto the PC. Command line first, and we got an IP address. 192.168.10.1. Ping 192.168.10.254 should be the firewall. There we go. Ping 192. No, what was the outside interface address? 198.51.100.4. Is that 192.168.51.100.4? We're not reaching that. 192. See if we can hit the. See if we can hit the. There we go. We're going through the firewall to the VRP, so we can technically hit that. So now we should ping 1.1.1.1. And this client now has internet access. So now we should be able to open a web browser. Now this machine technically has access to the internet from the access switch redundantly to the two core switches, to a redundant firewall, through a redundant outside internet switches, to a redundant internet failover ISP supplied routers, up to the ISP POP, and then on to the rest of the internet. So let's just double check that we can reach good old Google. And there we go. Uday's data center has internet access through a redundant firewall feed. We can test that. Let's stop firewall 1. I'll ping 1.1.1.1. And you'll see that we are pinging. This is the switch is up. So what's happening now is the path from this machine is coming up here, coming across here, going up firewall 2, coming up into the switch. Technically it's then traveling across the trunk, going over ISP1 and then up to the POP. And then technically, if this was to fail, it would still carry along here, across the trunk, up to the firewall 2, come through here, but instead of going across that way and up there, it would then go up here to router 2, and then up and onto the internet. So there is always a path available for the traffic to flow. So now if I start firewall 2 back up, whilst we're waiting for that to come back up, I'm going to look at. We can see it's still pinging, so we shouldn't see anything change. So let's look at the spanning tree. Let's start with the access switch. So config tree, config spanning tree, VLAN 10, priority. You're going to be like super high. So we're going to go calculator. So we have got 4096 by 3. So what I'm going to do, what I'm doing here is the same as how when we did with the routing, we used like that metric of 200 to float a route. What we're doing here is we're manipulating a similar scenario, but we're manipulating it at layer 2. So when manipulating it at layer 2, we're manipulating the spanning tree protocol. So what I'm going to do here is I just want it to make sure that I want you to be, basically I want you to be like God. Want the second one over here, spanning tree, VLAN 10, you will be, actually, yeah, I'm going to set you to 4096. You can be the secondary. Okay. Right, so now I want to do a show spanning tree VLAN 10. What we should see now is that this switch is the root bridge, and all of its ports are open for that VLAN. So this one here going towards the firewall, G1/0. This one got the trunk over to the second switch. This one down towards the third switch. Switch 10. So spanning tree VLAN 10. It's not the prime. You see, it's not the root bridge. You can see that it's got a priority of what I set. And you can see that the root bridge is available via 0/1. So this is the root, which is what it knows. But it's still got the other ports opening in forwarded, which is what we want. And then down at the access layer, where we haven't got any other operations going on, we can see that because the path to the root bridge is via this link 0/0, this one is open and forwarding, and basically G0/1, there is technically like a red, it's blocked. So no forwarding is going on here. So that stops a loop at layer 2. Now you can see, so from here, traffic will go this way, across here and up. And then if this link was to ever go down, the traffic would then take the next path and come up this way. And those layer 2 links will now fail over happily without causing any problems. Now, if we close those and we have a look at Uday's test PC, he is still happily pinging the internet. So now if we trace, you're telling me it doesn't have traceroute installed. That's why I built a new machine. So let's do an SDU apt install inet utils trace route. How dumb is that it doesn't install it? So the test 1, 2, 3. Got to browse YouTube. So trace route to what was the point at the top? 202.0.11, so 203.0.113.1 should technically be the ISP point here, so we can see that we have gone to the address on the inside interface of the firewall. We then hit the ISP supplied router of 198.51.100.2. Obviously that's the physical address there, and then we come up to there. So if we then try and scan to secondary link, which was they were 5 at the ISP side, we can see again we are coming from our machine up to the correct port. We're then going to the primary router, and then we're going there. So like we're now a mix of layer 2 and layer 3. So we've got traffic being routed and traffic being switched. So if we cause an ISP failure, we will stop R1. We should see, now that we've stopped R1, when we do the test to .1, you can see that the first test, when we went to that address, we went to here. We then went obviously on to ISP router 1 and up to the leg there. But what we've done now is we've gone to firewall 1. The firewall 1 is still routing it to this address, but it's gone over to .3 is here, and then it's taken this path up and to the internet. So we have fully redundant internet at this location. Everything is operational and failing over. From here, we can now build out. In later videos, what I'm planning to probably do is we will remove these outside switches, and we will do it like how we would normally do. So these legs from the outside interfaces of the firewall will come down into the same switch. We will feed VLAN quad 9 down into here as well, and it will be VLAN separated, and it will reduce the need to have additional switches in the way. So we can do that, and then the next step would be to remove some of this spanning retree redundancy that we've got going on down here, is to replace this with a VPC nexus, where we can have these links going to 2 separate physical switches, but they will be a port channel. So they would technically be seen as one interface, one pathway. So technically there'll be no need to have any kind of spanning tree protocol blocking. So instead of all the traffic coming up this one link at 10 gig, we could have both 10 gig links being used at the same time and take advantage of more bandwidth as more desks are added in this ground floor subnet, more traffic is being routed towards the firewall. So that's the plan of action for this next one. As we can see, everything is all working from the customer's perspective. They didn't notice or miss a penny or miss a beat that the internet had failed over. What we'll do now is we will simulate a failover of the Palo Alto. So what we'll do now is, if I switch firewall 1 off, and again, we still need to implement things like tracking because we haven't got a redundant link over to switch 2. We need to monitor this outside interface so that if, say, this device here was to die, then we know that what will happen is that the firewall will go, hey, this interface has gone dead. You need to fail over. The same as how we had to do for the ISP side of the equipment, where we had to monitor some form of tracking or trackable entity to be able to say, hey, we need to force a failover here. Because obviously if the switch dies like this, where I stop it physically like that, that's a physical failure, like someone pulling out the power. The power's gone to that device. So physically this one knows to take over, because these heartbeat links go, hey, I can't reach this device anymore. So as you can see, the device is still pinging. This device is dead. The client hasn't seen that the internet has gone down. Everything's functional. But if I was to switch this off, this would stay up the same as how we had here. So we would technically need to go in, do some manipulation to say, hey, you need to track the link from here to the ISP gateway or to this gateway. If you do not have a path, then you should fail over and use the secondary device. So again, you need to layer and layer and layer to make sure that you have full redundancy, and you need to test every scenario that you can think of. But at the moment, from the perspective of getting operational, we now have a 100% reliable internet feed here that is fully redundant, depending on if the routers go or if any of the uplinks to the ISP go down. The next phase will be to add the redundancy here by removing this requirement for 2 different switches and 2 different switches. And again, like I said, we can add in a VPC pair and redundantly then bring inch leg down from the gateways down into VLAN 999. Same with the outside. And because it's a VPC, again, it's a different type of failover because it's more of a higher end failover technology. It's seen again as one physical device to the firewall. So again, the firewall will go, hey, I can still reach ISP gateway 2. I can still reach the VRP address regardless of if somebody unplugged one cable, because the VLAN would still be available. So we'll look at that in a future video. Coming up next, I've got a video where we're going to look at some Wireshark packet capture, just to highlight the need to make sure that you stay secure and that you use encryption between devices. Don't rely on old technology such as Telnet or FTP, or accessing websites over plain HTTP. So the purpose of that next video is to have a lab where we can show the packets that are actually flowing from device to device, so that you can actually take a look at that in Wireshark form and see the information that us as network engineers can actually see. So that will be the next video. I hope you enjoyed this one, and you have an understanding now of how and what it takes to build a redundant infrastructure. And so I will see you on the next one. Please remember to hit that like and subscribe button. It'd be great if we can really sort of like grow the channel, and we can start putting some more content up. So I will see you in the next video. Have a good week.